Hi guys! Today we are going to do more mole conversions, but we're going to take it one step further, and I'll explain what that means in a couple of minutes with regards to atoms and ions. Just to remember, we are going to first go over the conversion factors that we talked about, or our equivalency statements. So first of all, if we have 1 mole, we know that in 1 mole there are 6.02 times 10 to the 23rd particles. Now, particles could be molecules, formula units, atoms, or ions, and I'll elaborate on that in a moment. The next is that is also equal to our molar mass, and remember our molar mass is actually grams per mole. We can find that on the periodic table. You learned how to calculate that last class, or 2 classes ago. Lastly, we could also look at the volume of 1 mole of a gas at STP. That's going to be equal to 22.4 liters. Today, we are going to be looking at this question. We're going to be answering this. How do we find the number of ions in a formula unit or the number of atoms in a molecule? And we're going to be using that to calculate moles of atoms or moles of ions within a sample. Before we get into that, we're just going to use an example that we are more familiar with, the dozen. So, if I need to make 1 dozen chocolate chip cookies, how many dozens of chocolate chips will I actually need? Now you can see here's our chocolate chip cookie right here. 6, we're going to have 6 chocolate chips in each cookie, so we will need 6 dozen chocolate chips. That's an equivalency statement just like up here. So 1 dozen cookie, just like 1 mole is equal to 6.02 times 10 to the 23rd particles. 1 dozen cookies is going to equal 6 dozen chocolate chip cookies. Similar thing.
6 dozen chocolate chips.
6 dozen chocolate chips. Exactly. Okay, so we're going to take this one step further and actually use this conversion factor to figure out how many chocolate chips I'm actually going to need. So the actual number of chocolate chips. First, I'm going to start with my given. I'm dealing with 1 dozen. So if I have 1 dozen cookies, okay, then I am going to say convert to chocolate chips. That is my first step that I always go back to. So first I'm going to say that in every 1 dozen cookies, I have 6 dozen chocolate chips. Okay? We okay with that? Then I use my equivalency statement that we all know about to write in my next conversion factor. So I'm trying to cancel out my dozen, and I'm trying to figure out just how many particles or how many chocolate chips I have left. Okay, so in 1 dozen, I have 12 chocolate chips. Okay, this cancels out, this cancels out. And then I end up with 6 times 12 is 72 chocolate chips. Now, I bet you guys are thinking, yes, we could have all figured that out in your head, which is really great, but you're not going to be able to figure out all of our chemistry that we're doing in your head. So this was just an example to help you guys to understand what we're doing and how we're going all the way, not just from a molecule, but we're going to use, these represent our atoms.
All right, so we're going to do another problem here. Again, we have the equivalency statement on the top here for you. You'll also see over here that we have the steps. If you've forgotten how we're doing these conversions, we're always going to start with our given, set up our skeleton. On the bottom, put the given unit. On the top, put the wanted unit. We're going to actually add in this step. It's going to be a mole-to-mole ratio, and you're going to see what that looks like today. Solve, and we'll check our sig figs and units. All right, so we're going to start with this question. Similar to how many dozen chocolate chips were in a dozen cookies, how many moles of hydrogen atoms are in 1 mole of methane? All right, so if we have 1 mole of CH4, how many moles of hydrogen atoms are there? All right, so you can see we have H4. So in 1 mole of methane, we have 1 mole of methane. We have 4 moles of hydrogen. And I'll put hydrogen atoms. Okay? Now, we're going to use that to do a mole conversion like we've been doing in class. How how many hydrogen atoms, right? So we're not actually looking here for molecules, formula units, or, well, we are looking for atoms, right? But this is atoms in a molecule. So in 2.5 moles of CH4, how many hydrogen atoms do we have? Ultimately, our wanted is atoms of hydrogen. So we're going to start with our given, and we set up our skeleton. 2.5 moles of CH4. We need to put our given unit on bottom. So we have moles of CH4 on bottom here. Now, remember that we are looking for atoms of hydrogen. So we need to first get into moles of hydrogen. This is what I'm calling the mole-to-mole ratio, okay? If you're in one unit, CH4, and we want to be dealing with a different one, hydrogen, you are going to use a mole-to-mole ratio. That's the only way you can go from CH4 to hydrogen, right? So mole-to-mole ratio. In 1 mole of CH4, we're going to fill in 1 at the bottom. How many moles of H are there? 4, okay? 4 moles of H, and that's what we figured out up here. Now, we can cross off moles of CH4. We have moles of hydrogen, but I want atoms of hydrogen. So, moles of hydrogen goes on bottom, atoms of hydrogen goes on top. Now we need it from our equivalency statement, right? Here's our equivalency statement. How many moles? 1 mole. How many atoms? Remember, particles can be atoms, molecules, or formula units, or ions. 6.02 times 10 to the 23rd, okay? Our moles of hydrogen cross off, and our unit that we're left with is 6.02 times 10, or is atoms of hydrogen. All right? Our answer then, when we do the math, yes.
Oh, yeah. We're going to multiply 2.5 times 4 times, remember your parentheses, 6.02 times 10 to the 23rd. And you want to remember that EE button for this equals times 10 to the x, right? Or, yeah, times 10 to the something.
And we'll go over that in class with you if you need. But when you multiply across the top, divide by the ones on the bottom, you get 6.02 times 10 to the 24th atoms of hydrogen. All right, so that's our final answer. We went from moles of CH4 to atoms of hydrogen. All right, we're going to look at one more problem, right? And this is going to now incorporate a mass, right? So we're going to be going from a mass to atoms. Okay, so again, we're starting with this introductory question. How many moles of chloride ions, Cl-, are in AlCl3? Because AlCl3 is an ionic compound, this is a formula unit. So instead of dealing in atoms, we're dealing in ions because it's made of ions. Okay? How many chloride ions are in AlCl3? Hopefully you come up with 3 chloride ions. Is equal to 3 moles of chloride ions is equal to 1 mole of AlCl3. All right? Now we're going to use that when we come down here. Now how many chloride ions are in 18 grams of AlCl3? Okay? Starting with our 18 grams. We set up our skeleton, and we're going to have to put our given unit on bottom. So, I'll do this one, you can do the next two. We have grams of AlCl3 on bottom. Now remember, what's at the center of mole highway? The mole. We always have to go back to the mole. So, we have grams of AlCl3 and moles. What's our equivalency statement? How many moles? 1 mole. All right? How many grams? Well, this is the molar mass. Conveniently, we've already calculated the molar mass for you over there in purple. The molar mass of AlCl3 is 133.33 grams per mole. Okay? And grams is gone. Now we have moles of AlCl3, so that's what has to go on bottom. Moles of AlCl3. Now, we're looking for, ultimately, chloride ions. So we need to go to moles of chloride ions. This is our mole-to-mole ratio. To get from AlCl3 to chloride, we need a mole-to-mole ratio. So, in 1 mole of AlCl3, we have 3 moles of chloride ions. 1 mole of AlCl3, 3 moles of chloride ions. Now on the bottom, moles of AlCl3 is gone. Bottom, we have moles of chloride ion. That's what we have here, so that goes on bottom. And on top, we're looking for ions of chloride. All right, so our top unit is going to be ions of Cl minus. Now, we're looking at our equivalency statement. How many moles? 1 mole. Bottom. And how many ions? Remember, ions are one of our particles. 6.02 times 10 to the 23rd. Okay? Multiply across the top.
Sorry, I'm going to erase this.
Divide by the bottom. And we end up with 2.44 times 10 to the 23rd ions of chloride, or Cl minus.
Sorry.
Chloride ions. All right, so that's it. We'll see some similar problems. They'll be a little different. We'll incorporate liters as well in class, but this is the basic of how you go to ions and atoms.